Hello, family. Welcome to another session of Maths Fanatics 24/7. In this video, we're going to be looking at the first 5 terms of the quadratic sequence defined by Tn equals to n squared plus 2n plus 1. So they want us to find the first 5 terms, okay? The first 5 terms. So it means they need term 1, term 2, term 3, term 4, and term 5, right? Those are the first 5 terms. And you're just going to take these numbers and substitute on the formula, right? So the first one will be T1. So T1, we can see that is going to be in bracket squared plus 2n, plus 2 in bracket 1 plus 1. Then you do the same for T2. That'll be 2 squared plus 2, 2 plus 1. Then you do 2, 3. It's 3 squared plus 2. And then there's a 3 there. Then plus 1. Then you do T4. It's going to be 4 squared plus 4. Plus 2 in bracket 4. Then plus 1. So here we're going to have in bracket 5 plus 1. You have 2. You have plus. You have 5 squared plus 2 T5. I'm sure you have seen that the values in the brackets are changing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Everything remains the same, right? Now let's see what the answers will be. Here, the first answer will be 4. The second answer will be 9. The third answer will be 16, because 9 plus 6 is 15 plus 1, yes. And then this one will be 25. And then lastly will be 36. Therefore, the first 5 terms of that pattern, it's 4, it's 9, it's 16, it's 25, it's 36. Okay, perfect. So now let's see. Let's erase this part. Remove. Oh, sorry. It also removes my thing. Let's see. What happened, ladies and gents? Let me check quickly. Let's go back there. Oh, here we go. So it removes even my writing. So let's just rather do this. And then I'll just use a normal eraser here, just to remove this quickly. Okay. Awesome. So we can now go to 2. On 2, they want us to. Okay, let me increase the size of the pen. So ladies and gents, on 2, they say determine whether each of the following sequence is a linear sequence or a quadratic sequence or neither. So here I'm going to be selective. I'm going to be selective because the repetition is the same basically. They follow the same trend, this pattern. So I'm going to choose A as the first one. So let's do 2A here. Remember, if a pattern is linear, there will only be the first difference that is constant. If it's quadratic, there will be a second difference that is constant. So the first difference won't be constant for a quadratic pattern, right? Okay, let's do the first one. So you have 6, you have 9, you have 14, you have 21, you have 30. Now let's do the differences. These are the first differences, right? Sure. So you start with this minus that. Remember, 9 minus 6 is 3. 14 minus 9, it's 5. This minus that, you can see is going to be 7. This minus that is 9, right? So let's check. Is this first, this we call first differences? Ne? Are the first differences constant or not? No, they are not constant. The first differences are not constant. But I need you to see some pattern here. Ne? The first differences forms another pattern. This pattern is called a linear pattern. Do you see? So the first differences forms a linear pattern. It is a very, very important thing to know that the first differences of a quadratic number patterns forms a linear pattern. So when I see the first differences being linear or forming a linear pattern, I know that, okay, this is a quadratic pattern because the first differences of a quadratic pattern are linear. So I'm going to do the second differences now, which is there, and there. Then 5 minus 3, I see is 2. Then I know that everything is 2. Therefore, you always, if they say show that, you always need to prove. Therefore, you're going to say quadratic. Then you give a reason. You say because, this is the symbol for because, constant second difference. Okay. Sharp. Or some people just write this. Constant second difference. Constant. We see. Perfect. And then the other one that I'm going to do will be B. Let's try B. So we need to quickly erase this part. Let's see. Okay, so we're going to try B now. Okay. Very quick, sharp. So let's do B. Okay, so on B we have 3, we have 9, we have 15, we have 21, we have 27. Let me just verify 3, 9, 15, 21, 27. Let's do our first differences. Our first difference is going to be 9 minus 3, which is 6. Right? Is going to be 15 minus 9, which is how much is it gonna be? It's 6. Oh, I'm doing H actually. Okay, that's fine. So I did A, I'm doing H now. It's fine. This minus that is gonna be 6. This minus that is gonna be 6. I'm sure, ladies and gents, that you can therefore see that this pattern, right? It's linear pattern. You need to know that the linear pattern is called arithmetic as well. Arithmetic. You're going to say because constant first difference. Okay. Now let's go to B. B, we have 1. We have this. We have that. We have 31. We have 49. And then there. This minus that is going to be how much? 6. This minus that is going to be how much? 10. This minus that is going to be how much? 40. This minus that is going to be how much? Let's see, it's 18. Right. Then you can see that this pattern, the first difference is not constant, right? But you see that we're always adding a 4 here. So the first difference is linear, which means this pattern will be quadratic. But you just need to show that we are always adding a what? A 4. And then you're going to write the conclusion to say, therefore, quadratic number pattern. The reason being a constant second difference. Now, I'm not going to write that to save time. Let's move on to the next question. Okay, the next question is going to be C. Okay. So let's do the next question, which is M. Okay, Okay, let's do M and L actually, because the rest, guys, is just the repetition. I'm just going to do this one and that one, and then we can move on. So here I have, okay, didn't erase properly there. Okay, sharp. So let me move this a little bit. So I have 3p squared, 6p squared, 9p squared, 12p squared, 15p squared, and so on. Let's do the first difference quickly. You can see that 6p squared minus 3p squared is going to be 3p squared. This minus that gives you 3p squared again. This minus that gives you 3p squared, and then 3p squared. So you can see that this pattern is a linear pattern because there's a first constant difference. You always write those things down, but to save time, I wrote them for the first two. Ne? So you will always use those reasons, right? So that was our L. Let's do our M now. So M, you have 2K, you have 8K, you have 18K, you have 32K, you have 50K, right? And then we have to do our differences and see what we have. 8 minus 2 is 6K, 18 minus 8 is 10K, 32 minus 18 is 16K, and then this minus that is 28K, right? Did I subtract properly, guys? No, this is 12, I think. Let's see here. Oh, it's 14 here, guys. It's 14, and here it's 18. My mental math is not mentally today. Okay, so that's 14K. And then I can see that, okay, the first difference is not constant, so I need to do the second difference. 10 minus 6 is 4. 14 minus 10 is 4. 18 minus 14 is 4. Then you can see that the constant difference, I mean, is the second one. So you're going to say quadratic. The reason is because there's a constant second difference. Okay, perfect. Now let's go to the next question. The next question, ladies and gents. The next part of this video is this, right? We are given on 3. They say given the pattern 16, X, and 46, right? To be what? To be a linear pattern, okay? A linear pattern. So the thing with linear pattern is this. I know that this is given by T2 minus T1, right? Then I know that this part here is given by T3 minus T2 and so on. Sharp. And then what I know about a linear pattern is the differences in the first row are equal. So T2 minus T1 will be exactly as T3 minus T2 because the first difference is constant, because they told me it's a linear pattern. So I can now substitute. My second term is X, my first term is 16 equals to 46 minus X. Then I'm going to move the X that side, which becomes 2X. Okay, let's not skip steps actually. It's going to be X plus X because it was negative. It becomes positive. Then it be 46 plus 16. Right. What is 46 plus 16? Let's see quickly. I think that is 62. Yeah, that's 62. And then you have 2X here, X plus X. Then you divide both sides by 2. So divide by 2, you are left with X there. 62 divided by 2 gives you 31. Then that's your answer for X. All right. Sharp. Let's do 4 now. On 4, they want us to, they give us the Tn equals to 2n squared. And ladies and gents, we can see that this is a quadratic number pattern because of the square part, right? The n squared. Always, if you have an n squared in functions, x squared is parabolic function or quadratic function. On number patterns, if you have n squared, we call it a quadratic pattern. It's just a parabola, basically. Ne? You need to know that when we get to more advanced and application questions, that a quadratic number pattern is just a parabola. You'll see as we go, as we do more practices in this playlist. Ne? Awesome. So now they say for which values of n? So they want us to solve for n, right? Which means they must give us the Tn. So they say Tn equals to 2, 4, 2, which means here I can replace the Tn with 2, 4, 2. Okay, let's do it. 2, 4, 2 equals to 2n squared. So here I prefer to write it this way, which doesn't make a difference. I prefer the unknown variable to be on my left. 2, 4, 2. Sharp. So I'm going to divide both sides by 2. Then I have n squared equals to, what is 2, 4, 2 divided by 2? 2, 4, 2 divided by 2. It's 1, 2, 1. 1, 2, 1. Then I can square root both sides. Can square root there. Remember, usually when we square root, you put plus minus. Ne? But on number patterns, remember, n elements of natural numbers. Remember, natural numbers are always positive. So you don't need to do the plus minus. You know that your answer must be positive. Then you are going to say n equals to 11. Then you can make conclusion to say, therefore, the 11th term will be equal to 2, 4, 2. Right. And that's it with that, ladies and gents. Okay, let's see this. Let's erase. Sharp. Process that for me. Gone. Okay, sharp. So now we're gonna do number 5. Number 5. Let's do number 5. Okay. Given the Tn to be that, they want us to find T11. You see? So here they give us the n to be 11. Remember, this is usually Tn. So it means they replace the n with 11, which means we need to replace our n with 11 on the pattern. So I'm going to replace that. So I'm going to have T11 equals to 3, 11 squared. Let's see what that gives us. So 3 in bracket 11 squared, right? That gives us 363. 363. Then that is number 5 for you, right? Let us now do number 6. On number 6, we are given a quadratic number pattern for which values of n, so they want us to solve for n, where the Tn will be equals to 85. So we're going to replace the Tn with 85 because that's what they gave us. So we're going to say 85 equals to n squared plus 4, right? And then you take this, that side, you get 81 equals to n squared. Therefore, you can square root both sides. I'll just leave it like that. N squared. And then here you always have to show that n are elements of natural. You are giving them the reason why you are not, you are giving us the reason why you are not plus minusing. Remember, when you square root, you need to plus minus, unless you have a reason not to do so. So n will be 9. So which means the 9th term will give you the value of 81. Okay. Perfect. Let's go to the next question. Let's go to the next question, ladies and gents. So we are on 16 now. Ne? 16, they say a quadratic number pattern or a quadratic sequence has a second term equals to 1. Okay. So I'm going to, they haven't gave me term 1 yet, but I know that the second term equals to 1, as the statement says here. Second term equals to 1. A third term equals to -6. Okay, -6. And a fourth term equals to -14. Okay, sharp. So -14. Okay, I'll just call the first term x since it's unknown. Let's call the first term x. Sharp. Then they say the first question says determine the second difference of this sequence. Okay, that should be fine. Remember, we just have to subtract here. 1 minus x will give you 1 minus x. You can't do anything. -6 minus 1 is going to give you -7. Ne? And then you are going to have this now. Let's see. -14 minus -6 will give you -8, I think. Let's just confirm that. So we take -14. We need to subtract with -6. So in bracket, -6. That gives us -8. Okay, that's fine. Then now we're gonna proceed. Here we're going to have this, ne? We're going to have -7, and then we're gonna minus by that guy. So -1 minus x, ne? This will give us how much? Let's see. -7, this will be -1, so you're gonna have equals to -8, and then this and that will give you plus x. So this part here gives, we can just erase this because we get -8 plus x there. Okay, let me write it nicely. So this gives us -8 plus x, as you saw when I simplified. Then let's see what does this gives us. -8 minus -7 will give you -1. Let's confirm. -8, there's nothing wrong with confirming, ladies and gents. Then -7, which gives us -1. You see, sharp. And then you can see that they told you that this is a quadratic number pattern. You already know that the second difference, therefore, second diff is equals to -1. Do you see it? Perfect. That is A, because the value of the second difference is there. Sharp. Now we can do B. On B, they say hence or otherwise calculate the first term. So obviously, guys, remember the second difference of a quadratic number pattern is the same. It's constant. So I know that -8 plus x will be also the same as -1, because the second difference is what? Is equal for a quadratic sequence. Then I can see that, okay, x is basically -1 plus 8, which means I have how much here? I have 7. So the first term will be 7. Therefore, you're going to say, therefore, the first term is 7. And then we're done with that question. We're going to do the last question of this video. Okay. In this one, they say the first term of a quadratic number pattern is 4. So the first term is 4. The third term is 34. So they didn't give me the second term. So I'll write x for the second term, and then I'll put that, ne? Sharp. And then they say the common second difference is 10. Okay, let's subtract this minus that minus, it's x minus 4 is going to be x minus 4. There's nothing we can do there. Then this one will be 34 minus x. There's also nothing we can do. Right. Then we need to multiply these two, subtract the two together. So you have 34, right? You have 34 minus x, and then you need to minus the x minus 4. Let's see what this simplifies to, right? It's 34. Obviously, you'll be using a pencil here, simplifying, and then you'll write whatever the answer is there. I usually do it on the side, ne? So let me just do this, 34 minus x plus 4. I'm distributing the negative in here. So I get that, right? Sharp. Now, what does that simplify to? It's going to be 38, right? Minus 2x. So here I have 38 minus 2x. And I know that this is the second difference, right? This is the first difference. And they told me that the second difference is equals to 10. You see? So I can basically solve for x now. I can say 38 minus 10 equals to 2x. This goes there, that comes in. And then this is 28 equals to 2x. Then you can see that, okay, the x value is basically what? Over 2 over 2. Therefore, x is equals to 14. Right. Now you can easily hence determine the first 6 terms of the sequence. So that is easy. I'll show you now. We don't need the formula to do that. Getting the formula is just a long method. You need to know how to get the value of the terms without getting the formula. I'll show you now quickly. So you have 4, you have 14, right? You have 34. You just need one more. You need one more. You need one more. Then you have your first 6 terms, right? So you're just going to do this, ladies and gents. It's a very easy thing to do. Ne? I'll show you now. Sharp. So what is the difference between 14 and 4? The difference between 14 and 4 is 10. Right. The difference between 34 and 14 is 20. Right. Which means, ladies and gents, that here we're going up in tens. Remember, in the beginning of the video, I told you that it is very important to know that the first difference of a linear pattern forms what? The first difference of a quadratic pattern forms a linear pattern. So here I can see that, okay, 10 plus 10 gave me 20, which means 20 plus 10 must give me 30. Then here I'm going to have 40, then 50, because I know that this part here must give me a linear pattern. Right. Sharp. I wanted to draw a circle, pardon that. Sharp. So now, I want you to observe something. 4 plus 10 gives you 14. 14 plus 20 gives you 34. 34 plus 30 will give you this term there. So it's 64 here. You see it? Right. I'm sure that makes sense. And then 64 plus 40 gives you 104, which is there. Right? And then this plus that gives you 154. Right. And then this was the quickest way to do it, but some people would want to firstly get the formula. So you can do this, that. You know that the differences are 10, 10, 10. You have 2a here. You have this one here, remember, is 3a plus b. Then that one is a plus b plus c. So I can see that, okay, 2a equals to 10. Then I divide both sides. I see that a equals to 5. Then I'm going to have 3 times 5 there, plus b equals to 10. Therefore, I can see that b will be 15 minus 5 to get 10. So b will be negative 5. And then I'm going to have 5, which is my a, minus 5, which is my b, plus c will be equals to 4. Then this cancels. The c is 4. And then therefore you can see that, okay, the Tn formula is going to be Tn equals to 5n squared minus 5n, and then it's going to be plus 4. Right, and then I can show you, for example, let's do the term number 2, for example. T2, then you get T, but you need to do T1, T2, T3, T4, T5. I'm sure you see that is tedious, guys. You need to know how to use that method. But let's just verify with T1. So 1 squared minus 5, 1 plus 4. That is basically 5 minus 5 plus 4, which gives you 4. That's the first term, and so on and so on. That is the end of the video, ladies and gents. If you found it helpful, please don't forget to share with family and friends, and keep on looking for more video. And also subscribe if you haven't, leave comment, share, like, and everything you can do to boost our channel so that it can be able to reach more people and help them as well. Thank you very much for being with me. Aluta continua. Tango.